Okay, so this is our last little lesson in our trigonometry unit, and it should be pretty quick. We've already talked about a lot of trig things. We've talked about basic trig functions in right triangles. We've talked about Pythagorean theorem. We've talked about solving right triangles to find all the missing sides and angles. We've talked about how to do that with non-right triangles, including law of sines and law of cosines. And then we've talked about some applications of all of those things, including angles of elevation and depression. So the last thing we need to talk about is there is a way for us to find the area of a triangle when it's not a right triangle using some trigonometric functions. So I want to show you that right now. So for normal right triangles, or if they give us the appropriate information, area is really easy. Normally the area of a triangle is going to be 1/2 times base times height. But the requirement there is that these two pieces of information, the base and the height, have to be perpendicular to one another. Otherwise, it's not considered a base and a height. So notice that the triangle that I have given, I could pick any side to be the base, but the problem is I don't have a height here. So I'm going to go ahead and set up my formula using the information that I know. So I'm going to say the area is equal to 1/2. I'll call the base 10. And then I'm just going to draw a blank here because I don't know the height, and I'm not going to be able to solve it until I do. So let's kind of take a detour and see if we can figure out a way to find that height using other information given in the triangle, because they do give us another side length, which is the 7 centimeters, and an included angle, which is the 22 degrees. So I could actually draw a height. I know it needs to be perpendicular, and it's going to need to come from a vertex. So I'm going to go ahead and draw this height right here inside the triangle. I know that's the same height that I'm going to need for my formula. And I can actually find that length using this other information, because notice now I drew myself a little right triangle here. So if I want to set up a trig ratio, I know that I've got this opposite side, which I'm calling the height. So don't get that h confused with hypotenuse. And then I have the 7, which is the hypotenuse. All right, so if I set this up, opposite hypotenuse, that gives me sine. All right, so I've got sine of 22 equals the opposite, which is that height I'm curious about, over the hypotenuse, which is 7. And I remember in my formula, the part that I'm missing is this height. So I'm going to go ahead and put this over 1 across multiply so I can get height by itself. So that's going to be height equals 7 times the sine of 22. Now you could work that out, but I'm actually wanting us to see a generic formula here. So I'm just going to go ahead and replace this whole section into my formula up here. And that's going to give me area equals 1/2 10 times 7 times sine of 22. All right, so thinking about this formula, I want us to just kind of go generic for a minute and think about what are all of these pieces. So notice that they've given us, all of this will give you the height of the, not the height, the area of the triangle. These two are both side lengths, so they are obviously going to have to give us 2 side lengths for this formula to work. And then the angle that they give us, if this is going to be sine, when we set that up, the angle they have to give us ends up being what we call an included angle, because it's the angle between the 2 known sides. So this is the included angle. So no matter which 2 sides, as long as they give us an included angle, we can use this formula. So notice that it's very similar to the original formula for the area of a triangle. We just have to make some adjustments because the height itself is not given. Let's look at one more example of just how to set this up so that you can make sense of this before you practice tomorrow. All right, so in this example, remember, my formula starts out very similar to the way that it would for a regular triangle, for a right triangle. So this is area equals 1/2. We're going to multiply, and we have to check that they give us 2 sides, and that they give us an included angle, which is the angle in between. And this is true. 142 is the angle directly between the two sides they've given us. So if I set this up, I'm going to get area equals 1/2 times 3.2 times 4.7 times the included angle, and we're going to use sine of 142. In this formula, it will always be sine, so just make sure that you remember that. And if I go ahead and type this into my calculator on this one, I'm going to get the area is, we're rounding, so I'm going to say approximately 4.6. And since it's area, we want to make sure we use square units, so that's going to be meters squared. All right, so this is a quick, easy way for you to find the area of a non-right triangle.